Welcome to Learning with UNP. In this session of Python for Data Science, we are going to understand about list manipulation. That includes list sorting, using customized sort function, using case-sensitive and case-insensitive sort functions, and finally using reverse copy join methods. Let's begin with understanding sorting the list. Sorting a list arranges its elements in a specified order, typically either ascending or descending. In Python, the sort method or the sorted function is used to sort list. By default, sorting is done in ascending order. Sorting allows for easier data organization and facilitates various operations such as searching and comparison within list. Ascending sort involves arranging elements from smallest to largest. Descending sort involves arranging elements from largest to smallest by setting the reverse parameter to true. Here is a syntax to do this. This line is used to sort a list in ascending order. You can use the sort method on the list itself. This rearranges the elements from smallest to largest. This line is used for descending order. You use the same sort method but with the parameter reverse equals to true. This flips the sorting order, arranging the elements from largest to smallest. Let's look at the pseudocode representation of it. Step 1. Initialize a list variable mylist with some elements. Means start by creating a list variable named mylist with elements. Step 2. To sort in ascending order, call the sort method. Means for ascending order, use the sort method on mylist. This organizes the elements from smallest to largest. Step 3. To sort in descending order, call the sort method with reverse equals to true. Means for descending order, use the sort method with reverse equals to true. This arranges the elements from largest to smallest. Here are three examples that illustrates how sort method is used to arrange list elements in both ascending and descending order. In the first example, we have two lists, mylist containing numeric values and mylist2 containing strings. Both lists are printed as they are initially defined. Let's execute and check. As discussed, here is the output. In the second example, we sort mylist and mylist2 in ascending order using the sort method. This reorders the elements in each list from smallest to largest for numeric values and alphabetically for strings. The sorted lists are then printed using print statements. Let's execute and check. As discussed, the sorted lists are printed here. In the third example, we sort mylist and mylist2 in descending order by specifying reverse equals to true in sort method. This flips the sorting order, arranging the elements from largest to smallest for numeric values and in reverse alphabetical order for strings. The sorted lists are then printed accordingly. Let's execute and check. The lists which are sorted in descending order are printed here. The fourth example here illustrates how the sort method in Python works on list. Mylist3 is a list containing different types of elements like numbers, strings, even another list, etc. The sort function is used to arrange the elements of the list in ascending order, but it can't sort elements of different types. So, when you try to sort mylist3, which has a mix of types in it, it throws an error shown here. To sort it, you need to make sure that all elements are of the same type that can be sorted, like numbers or strings. Over here, let me explain you what is the cause of this error. When you use the sort method in Python to organize a list, it needs to compare elements to figure out their order. But if the list has different types of data like numbers and words, Python gets confused because it doesn't know how to compare them fairly. For example, it's easy to say which number is bigger, but comparing a number to a word doesn't make sense. So Python gives up and says it can't sort the list because it's too mixed up with different types of things. The same is explained here. Now let's understand about customized sort function. Python's sort method and sorted function accept a key parameter which allows for customized sorting. The key parameter takes a function that extracts a comparison key from each list element. Both sort method for list and sorted function for any iterable allows you to customize how the sorting is done using the key parameter. Here is the syntax to do this. This line allows you to sort the list mylist based on a custom rule defined by the function. This function determines how elements are compared for sorting, enabling you to sort the list according to the specific criteria without altering the original list. Let's look at the pseudocode representation of it. Step 1. Initialize a list variable mylist with some elements. Means start by creating a list variable called mylist and fill it with some elements. Step 2. Define a custom function to use as the key. Means create a function that defines the sorting criteria. This function will be used by Python to determine how to sort the elements in the list. Step 3. Sort the list using the custom function as the key. Means apply the custom function as the key parameter in the sorted function to sort the list based on custom criteria. Here are two examples demonstrating customized sort function. The first example demonstrates how to customize sorting behavior using the key parameter. In this example, we start with a list of strings, my list containing apple, banana, cherry, and date. Initially, we print the list as it is. Then, we use the sort method with the key parameter key equal to length to sort the list based on the length of each string. This means that the strings will be ordered from shortest to the longest. After sorting, we print the list again, showing the strings now arranged by their lengths. Let's execute and check. As discussed, here is the output. The second example demonstrates how a custom key function can alter the sorting criteria. In this example, we have a list called mylist containing strings apple, banana, and cherry. We define a function called custom key that takes an item and returns its reverse using the slicing item mentioned here. We then sort my list using the sort method with key is equal to custom underscore key, which is a function that sorts the strings based on their reversed versions. We print the sorted list using the print statement. Let's execute and check. As discussed, here is the output. Now, let's look at case-sensitive sort. By default, sorting strings in Python is case-sensitive. This means that uppercase letters are considered to come before lowercase letters because their ASCII values are lower. This can lead to results that might not be intuitive if you are expecting a case-insensitive alphabetical order. Here is a syntax to do this. In this line, the sort method sorts the elements of my list in place, arranging them in ascending order. For strings, this means that they will be ordered alphabetically and case sensitively with uppercase letters coming before lowercase letters. Let's look at the pseudocode representation of it. Step 1. Initialize a list variable mylist with some elements. Means create a list called mylist with some elements. Step 2. Sort the list. Sorting will be case sensitive by default. Means use the sort method to arrange the list. By default, this sorting is case sensitive. This example demonstrates how case-sensitive sorting works in Python. In this example, we start with a list called mylist containing the strings apple, banana, cherry, and date. Initially, we print the list as it is. Then, we use the sort method to sort the list. Since sorting is case-sensitive by default, uppercase letters are sorted before lowercase letters. As a result, banana, date come before apple and cherry in the sorted list. After sorting, we print the list again to show the new order. Let's execute and check. As discussed, this is the output. Now, let's look at case-insensitive sort. To perform a case-insensitive sort, you can use str.lower function as the key parameter in the sort method. This normalizes the case of strings before comparison, ensuring that the sort order is not affected by whether the letters are uppercase or lowercase. Here is a syntax to do so. This line sorts the list in a case-insensitive manner. It converts each string to lowercase for comparison, ensuring that the sorting order is alphabetical regardless of the original case of the letters. Let's look at the pseudocode representation of it. Step 1. Initialize a list variable mylist with some elements. Means begin by creating a list called mylist containing some elements. Step 2. Sort the list using str.lower as the key for case-insensitive sorting. Means use the sort method on mylist specifying key equals to str.lower. This key parameter ensures that the sorting process treats all letters as lowercase, enabling case-insensitive sorting. This example here mentioned illustrates how to achieve case-insensitive sorting in Python. In this example, we start with a list called mylist containing strings as banana, apple, cherry, date, UNP, and students. Initially, we printed the list as it is. Then we use the sort method with key equals to str.lower to perform a case-insensitive sort. This means that uppercase and lowercase letters are treated as equivalent during sorting. After sorting, we print the list again to display the elements in alphabetical order, ignoring case differences. Let's execute and check. As discussed, here is the output. Now, let's move on to understanding the reverse method. The reverse method reverses the elements of list in place. This operation is performed in place, meaning it modifies the original list directly without creating a new one. After applying reverse method, the last element of the list becomes the first and the second last becomes the second, so on and so forth, effectively flipping the list in opposite order. This syntax is used to do it. It will reverse the order of elements within the list, my list, in place. After this operation, the first element of the list becomes the last, the second becomes the second last, and so on. The list is modified directly without creating a new one. Let's look at the pseudocode representation of it. Step 1. Initialize a list variable mylist with some elements. Means start by creating a list named mylist with some elements. Step 2. Call the reverse method to reverse the elements of the list. Means use the reverse method to reverse the order of elements within the list. Here are two examples demonstrating reverse method. In the first example, we start with a list called mylist containing the elements 11, 21, 32 and 43. Initially, we print the list as it is. Then, we apply reverse method to reverse the order of elements within the list. After the reversal, the list becomes 43, 32, 21 and 11 and we print it using the print statement. Let's execute and check. As discussed, here is the output. In the second example, we have a list, mylist, containing different data types, including integers, strings, floats, list, and booleans. Similarly, we print the list before and after applying the reverse method. The reversal doesn't affect the types of elements, it simply changes their order. Let's execute and check. As discussed, this is the output. Now, let's understand about copy method. Creating a copy of list can be done using the copy method, list slicing, or the list constructor. The copy method allows you to create a new list that is a duplicate or replaces an existing one. This is useful because if you modify the new list, the original list remains unchanged. Without using copy, if you simply assign one list to another, both variables will refer to the same list and changes to one will affect the other. By using copy, you ensure that the two lists are independent, which helps prevent unintended side effects when modifying the list. This is especially important when working with complex data structures or when you need to preserve the original data for later use. Here is a syntax to do so. This line creates a copy of the list mylist and assigns it to the variable newList. This ensures that the new list contains the same elements as my list, but they are stored as separate lists in memory. Any modifications made to new list will not affect my list, and vice versa, allowing for independent manipulation of each list. Let's look at the pseudocode representation of it. Step 1. Initialize a list variable mylist with some elements. Means start by creating a list named mylist with some elements. Step 2. Use the copy method to create a copy of the list. Means utilize the copy method on mylist to generate a duplicate of the list. This example demonstrates how to use copy method to create a duplicate of a list. In this example, we begin a list named mylist containing various data types such as integer, string, float, list and booleans. We print mylist to display its content. Then we create a copy of mylist using copy method and assign it to copy list. Finally, we print the output using print statement. Let's execute and check. As discussed, here is the output. Finally, let's look at the join method. The join method is used to concatenate or merge elements of a list into a single string with each element separated by a specified delimiter. This method is typically used with list of strings. The syntax to do that is shown here. This line concatenates the elements of my list into a single string, where each element is separated by the specified delimiter. The resulting string is assigned to the variable joined string. Let's look at the pseudocode representation of it. Step 1. Initialize a list variable mylist with some string elements. Means Start by creating a list named myList containing string elements. Step 2. Define a delimiter to join the elements. Means specify a delimiter that will be used to separate the elements when joining. Step 3. Use the join method to combine the elements into a single string. Means utilize the join method to merge the elements of myList into a single string. Here are two examples demonstrating join method. In the first example, we have a list called myList containing the strings hello and students. We specify a space as the delimiter. Using the join method, we concatenate the elements of myList into a single string where each element is separated by the specified delimiter. The resulting string is assigned to the variable joined string and it is printed using print statement. Let's execute and check. As discussed, here is the output. In the second example, we start with a list called myList containing the strings hello and students. We print the list as it is. Then we use the join method with a space as the delimiter to merge the elements of myList into a single string. Finally, we print the output using print statement. Let's execute and check. As discussed, here is the output. The similarity between these two examples is that they both use the join method to merge elements of a list into a single string with a specified delimiter. The difference lies in the initial step of the list. In the first example, the list contains capitalized strings hello and students, while in the second example, the strings are lowercase hello and students. However, this distinction does not affect the operation of join method, which concatenates the elements of list in both the cases, resulting in a string with same format. This is all about today's lecture. See you in the next lecture. Thank you.